All right, yesterday's lesson was posted, so this is today's one last, we have maybe two more concepts to really just touch on, plus your Nearpods should be a good review. You'll have 4 Nearpods next week. You have not had any homework all week, any formal homework. You were asked simply to review and catch up. You were asked to go to tutoring if you needed it, and some of you did come. And as I said in the syllabus and the weekly syllabus and in class, the tutoring is from 3 to 5. If they cancel for whatever reason the tournament or the Valorant match this evening, then I'm going home. So if you don't show up near 3, I won't know you're coming unless you tell me. So I'll be going home if the esports is not playing today. So obviously we don't have school tomorrow. We'll have one concept today and one concept on Monday. Today's concept is going to be this idea of eutrophication. And it's an interesting byproduct of the stuff we've been talking about: erosion, water, the water cycle, the nutrient cycle. All right, so I'm going to move on, okay? All right. Yeah, it's eutrophication, so this should be an O. Is that right? All right. So we talked about the water cycle. As you know, water goes in a cycle. And we have different reservoirs. We have groundwater, which kind of is kept from us. We have to go dig for it. We have ocean water, or I should just call it salt water, because there's various forms. Salt water, which is, again, not really usable, so I'm going to put these in brackets. So salt water is not really usable. Can we get fresh water from salt water doing what nature does, which is distill water? Yes, we can. We can filter it. We can filter the salt out or distill it, but that takes a lot of energy. So it's really not feasible. Yes, bless you. And then you have surface water, which we're used to here because we have Lake Erie. But surface water leads to things like rivers, lakes, and of course you have rivers or streams as well. Groundwater does break back out in the form, is accessible in the form of springs, which we talked about. And you can get groundwater from wells, which is another, and both springs and wells are pretty well filtered. When surface water forms pools in large pools, we call it wetlands, and wetlands help clean the water. Wetlands help clean the water, and wetlands also provide habitat, much needed habitat. All right, so when we're talking about the water cycle, then of course we have the whole evaporation and condensation and all this stuff that we talked about that you have in your packet that you did for work last week, and hopefully you get it. The carbon cycle is another one of those cycles we talked about. When it's balanced, a balanced carbon cycle, what goes, the carbon going into the atmosphere equals the carbon leaving. When that's happening, the system is stable. So what's happening with us is we're unbalancing the carbon cycle. And that unbalanced carbon cycle stems from deforestation, which means reduced ability to remove carbon. All right, so deforestation is unbalancing the carbon cycle. It also stems from burning fossil fuels. That includes things like oil, coal, natural gas. So burning and peat is a and an unbalanced carbon cycle unfortunately has the really super bad result of increasing global average temperatures, which, as we discussed, leads to increase in kinetic energy of the atmosphere. Yeah.
What is the last word say underneath natural gas?
Peat. Peat is, you dig it out of the ground, it's an organic substance. People use it as a soil additive to acidify the soil a little bit. You can also burn it, and people use it to burn. But it's pretty much a fossil fuel. So average kinetic energy in the atmosphere increases, which leads to all kinds of things. The melting of glaciers is an issue. We're going to call it a snowpack. And that by itself is a tragedy, but what's worse is that what that leads to is droughts, lack of water. One of the reservoirs of water for those hot summer days is the ice in the mountains melting and feeding our rivers and streams. If you don't have all that snow and ice that built up over the winter, then you have less available water. Remembering that a lot of the water is stuck in salt water in the oceans, in the groundwater, so we don't have that water available to us. Even though there's a lot of it, we can't access it easily. So melting of snowpack leads to the available. It also, the melting of the snowpack, including glaciers, leads to rise in ocean, or let's call it sea level.
Wouldn't we be able to force it back into glaciers? Because it's a way for it to get to the ocean. Can we just reverse it back?
But if it gets to a point like farther, it can't be reversed. Like no.
You mean the carbon?
No, I'm talking about, you know how like everything melts and like the Grand Canyon.
Okay,
It
all right.
goes through.
Yeah.
Some parts of it goes into the ocean.
Yeah.
It's a way for it
Can
to
we
stay
take it,
and
collect it, and
put
rather
back
than letting it go and then pump it back into could we conserve our water?
Yeah.
I think that's what you're saying, yes. Conservation is an important idea. We could conserve our water. We could reduce our waste. Well, how to reduce waste is the biggest way. But yes, we could, for instance, you could capture rainwater. And use it to irrigate. We do that already. We call those things reservoirs. I can't spell reservoir. Somebody spell it. Reservoir. Something like that. Is it E?
I highly doubt it.
Look it up. Hey Siri, how do you spell reservoir?
That's how it's supposed to look.
I think it's RESOUEIR.
It's RESERVOIR.
That's what I said.
No, let's not use the GD. SER. No? RE.
Yeah, VOIR.
See, I told you I didn't know how to spell it. It's weird. Irrigate. Hey, I'm not the best speller. Capture rainwater and use it to irrigate. We call these things reservoirs in places where we don't have a giant lake. A lake is a reservoir, right? Groundwater is a reservoir. Aquifers are reservoirs. These are places where water is collected and stored, and we can use it, and that would reduce the amount of fresh water going back in the oceans. That's really true. One other important part there, though, is do not or not to pollute. And pollution sounds like not a big deal, but did you know that right here in Ohio, there was a couple that owned a factory, a tanning factory. You know, they take leather and they tan the leather so that you can wear shoes, but you can't wear leather without first treating it. And the factory treated it, and they had a lot of poisons they couldn't get rid of them. No, they couldn't get anybody to take it away. So you know what they did? They dumped it in the river.
And here?
In Ohio. I'm not sure where it was. It was in this area. They ended up killing everything in the river. And kids playing in the river, they were exposed to the chemical.
Oh, shoot.
So pollution is not a really good idea. And I've shown you examples of the Ganges in India where millions of people on a holy day, you could talk to Mr. Krishna about it, what they do in the Ganges in India. They all go to the river and they bathe in it. It's a holy day. That's one of their.
It was him.
That's interesting. I did. Yeah. But the water's really polluted. And if you pollute the water, remember we have a limited amount of water. So not all pollution is simplistic. Not all pollution is something, I got it. I won't throw deadly chemicals into the river. Okay. All right, I won't throw my garbage in the river, right? Like, that's obvious stuff we can stop. Those people went to jail, by the way.
How long?
But I don't know, probably not long. But anyway, it's just the nature of the justice system. They have good lawyers, who knows? All right. But let's think about crops. Let's think about a farmer. Everybody here likes food, right? All right. So farmers have to plow the fields. They have to get rid of the weeds. The weeds and insects are a big problem for farmers, right? Because insects will eat the food. They'll eat the plants. They have to plow the fields, which means they have to make like furrows. We call them furrows. And then they plant the seed in the furrow. And out of the furrow grows, corn or wheat or whatever you're growing, soy. Does that make sense? Mm-hmm. So out of the ground, you have all these plants, and then the farmer can then collect it. But how do to grow this many plants in this small area, what happens is that the necessary nutrients for growth, there's four, and you need to write this down because you should know what they are. There are these nutrients that are required. Remember, these are autotrophs, so they make their own food. But even though they make their own food, these plants do have, they need nutrients. Just like even though you can eat potato chips all day, you need some vitamins and minerals. you need nitrogen, you need protein. So it's not enough to make sugar. The plants can make their own sugar and they put that sugar in corn, and then we can grab the corn and make corn flakes or high fructose corn syrup or whatever it is we're going to make. So in a cornfield, when you're going to go and collect them, the problem is that there's three substances plants need to grow in large numbers, especially, and that's potassium ion. They need nitrogen, potassium, and phosphate. Now, obviously, you know what phosphate's used for: DNA, RNA, ATP. Nitrogen makes proteins, and potassium is just one of those things that they really need. All the rest of the stuff they have. There are a couple other cycles that you learned about in your work from last week. That's the phosphate cycle, the phosphorus cycle. And the sulfur cycle. Those are long-term cycles. There's not really an imbalance. There is a kind of an imbalance in the phosphorus or phosphate cycle. It takes a long time to get phosphate to be released. Phosphate's is in rock. Phosphate comes from rock. And so we can't wait for rocks to break down. And then phosphate can be lost to the ocean because there's something called erosion, right? Runoff. We call it runoff. So what we do is, I want to say, I'm gonna go ahead and say a date, and I'm not sure about this. Somebody can check me and then correct me tomorrow, Monday if they want. But I want to say in the 1930s or something like that, maybe 40s, they came up with a synthetic way of making these substances.
It's like artificial.
It's an artificial way. We can do it in a factory now. In the past, you had to collect, in order to fertilize the soil, you went and collected poop, right? Bat guano was the best. You went and collected bat guano and giant, because, do you know what bat guano is?
No.
Bat poop, bat feces, bat poop. So where do bats live? In caves mostly. Bats, the little flying mammals. They hang from the ceiling and they poop while they're sleeping or whatever. And that poop goes to the bottom of the cave. Well, over a couple hundred or 1,000 years, that poop is real thick. It's like layers of thick poop that's kind of almost turned into a rock. Well, what we can do is we can go in there and mine it. We can dig it out, chop it up, and then we could use it for fertilizer. We use that. We use cow fertilizer, pig poop. Human poop isn't really that great, and it can lead to disease, so we try not to use that. But we could process human poop and use it with our garbage, our food garbage, and make compost. So we could do that, and then after a while, the bacteria find a balance, and we could use that product of the food waste and the poop mixed together and sitting in a box over about a season. You can then take that and use it on fertilizer safely. So we don't do that anymore because we have the synthetic fertilizer. This is fertilizer. These three things together are fertilizer. And it comes in liquid form, and you can spray it on the soil. Otherwise, if we didn't, the soil would not be able to support plant life because you wouldn't have enough nitrogen, phosphorus, and potassium to grow the plants. So we have to spray it on there. If you're going to grow as much food as we need, we have to use fertilizer. Now, some people want to use organic fertilizer, which is poop. It's poop. Or rotting food compost. But that takes a lot of effort. This is easier and cheaper. So fertilizer, everybody here does not, and I don't think very few people would be very happy if we were paying $20 for a hamburger, right? For a McDonald's burger. If you had to pay $20 for a McDonald's burger, I think people would be like, what? But that's what it would have to cost, something like that, if you're gonna use all organic until the supply chain gets to the point where you're able to make it cheaper. So chemical fertilizers synthetic fertilizers are the way we do it. And the problem is you got rain. Remember the water cycle. And what's the rain gonna do to that fertilizer? That's right. It's going to run off. It's going to run. It's on. Usually there's some kind of low ground, right? So the water hits, falls on the soil. The fertilizer's on the soil. The fertilizer dissolves in the water, and it goes into the groundwater, or it runs off on the surface of the groundwater downhill, and ends up where? Where does it end up?
Just make a puddle.
It'll make a puddle, but it'll end up in the water cycle. So usually where does all water run off into? Groundwater can come out in the spring. Surface water can run down into and all of it's going to go into a, come on, you guys know it. Where's it all going to go? Eventually the ocean, yes, but what before it gets to the ocean? A river, into a river or stream. And then, yes, a lake, and then it could flow into an ocean, into the ocean. Correct. That's right. So here's the problem. So you have a pond. I'm going to go ahead and draw a pond. Let's go ahead and say Lake Erie, and I'm going to show you some pictures of Lake Erie after this has happened. So you have a lake, the rivers. This happens in rivers as well. Happens in lakes. Happens everywhere. There's water. So if you have an area where there's a lot of fertilizer being used. Your neighbors might use it on their lawns. You go and buy fertilizer and you put it in a water can and you spray it. If you over-fertilize, use too much of that fertilizer, in here you would normally have a low level of potassium, nitrogen, and phosphate. Now you got a lot. Now what you get is what we call an algae bloom. So now you get algae growing on, where's it going to grow? It's going to grow on the surface. Why is algae growing on the surface? What does a photosynthetic organism need?
Sunlight.
The sunlight, that's right. So it needs sunlight. So algae can't live without sunlight. So it's waiting for the sun rays. It can only grow here on the cells, on the surface of the lake. You got what's called an algae bloom. So you get a thick carpet of algae on the surface. It's pretty thick. Now, the problem is that here's a result. I'll ask you this. I'll ask you a question rather than tell you. So if you have this algae bloom, the result is a lower oxygen level. How's that possible? Why did lower oxygen level when we have photosynthetic algae? Why is that a thing? Oh, okay. That's not a bad idea. It's not quite right, but it's actually not bad. I always was confused about this. I'll be honest with you. High school, it confused me in high school. It confused me in college. I was like, wait, don't algae produce oxygen? And so why would oxygen levels go down? Yeah.
Maybe like that because like the algae like thick, so it's like you know how we did it like the spring door, and like since it's so thick, it would like nothing.
I love that. Both of you guys are excellent thinking. I never thought like that when I was your age. So it really shows a good making connections that I wasn't able to make when I was in your seats. But yeah, that's a really good idea. And it's something like that. What happens is that the algae at the very surface gets light, but the algae below it doesn't get any light because it acts like a screen, right? So what happens to the algae right below it? It dies. So all this algae dies. And where does it go? It's going to go down to the bottom. So you get this bunch of dead algae at the bottom. So what happens to dead algae? It decomposes. That's right. Excellent. That's excellent. That's right. So you have decomposition. The decomposers like fungi and bacteria. They eat. This is a lot of good food for the decomposers. Excellent. So they increase the production of CO2, and they use oxygen. So what you get, because you have so many decomposers, because of the dead algae, you get an increase in CO2, you get a lot of oxygen use. So we have an increase in what we call biological oxygen. Let me write out the whole thing. Biological oxygen demand. So the system is demanding more oxygen than it can provide. So the system uses up all the oxygen. What happens to the fish?
They gonna die because they ain't got it. Because they ain't got oxygen.
They die.
Oh my God.
The fish die because they have no oxygen. So without that extra nitrogen, phosphate, and potassium causes an imbalance in the lake ecosystem, which causes an algae bloom. That algae bloom, the lower layers die, the bacteria and fungi eat it, they use up all the oxygen, and then all the animals in the lake die. So it's a bad, and of course the death of the fish, the decomposers even grow even more, don't they? Because they are eating the dead fish too. The bacteria and fungi are loving it. But then all the other life in the lake is over. Any questions on this?
So, if it's a constant cycle of feeding decomposers, how would you stop that?
Well, hold on. Let me say this. Eutrophication. Again, the spelling. Cation. So it's eutrophication. This is what it's called. Eutrophication. It's like putrefaction, right? It's rotting. It's like that in some ways. So the lake can actually eutrophy. It could the oxygen could be removed, and most living things will eventually die. So the answer to your question is, how do you stop this? You reduce this. You start to reduce the fertilizer. If you can stop the fertilizer from entering the lake, the potassium, the nitrogen, the phosphate, and it doesn't matter if it's human feces or if it's chemical. If you have too much phosphate, nitrogen, or potassium, you're going to get these algae blooms, and they cause real big problems.
I got a question.
Yes.
If it wasn't no trees and stuff, would we be able to breathe?
No.
No.
Without plants, there'd be no oxygen. We wouldn't be here.
So why they keep cutting them down?
Money.
Wait, so I got a question.
It's a competition for land.
So,
Oh, that's good.
if before humans could evolve,
He goes.
plants needed oxygen.
Oh, that's good.
Did plants need oxygen to survive first?
What a great question. What a fantastic question.
What he asked?
He has, no one in all the years I've been teaching, no one's ever asked that question. So he asked this, if plants need oxygen, and animals need oxygen, and plants make the oxygen, how did the plants start to begin with? So it started with not plants, it started with bacteria. It's a bacteria called Cyanobacteria. So this is another story, but it's worth looking at. It's called Cyanobacteria. They're pretty much the first. They're probably the ancestors of the ones we see today. They're little green rod-looking bacteria. They do photosynthesis. They do photosynthesis. They don't need that much oxygen. There was a little oxygen back in the day, not a lot. But there was a lot of carbon dioxide. There was a lot of CO2. So they took that CO2, made sugar, and they produced oxygen. These guys, they changed the atmosphere on the planet. They're the ones that provided the oxygen for the planet. They allowed plants to evolve. They actually were probably the first chloroplasts. So they became the chloroplasts when some eukaryotic cell swallowed them. They became the first plant. They're the parent of the first plant on the planet. So cyanobacteria, they literally changed the atmosphere. Where the atmosphere used to be mostly CO2 and very little oxygen in the past, long past. We're talking before the world as we know it existed. And then today, obviously, we have lower CO2 and higher oxygen. So now animals can live and plants can live, and they're fine. Now, these bacteria made their own oxygen. They were so good at it, they made more oxygen than they could use. And over millions of years, they literally changed the atmosphere and allowed life as we know it to exist. In fact, the Earth used to be not blue, but purple.
That's cool.
Because the bacteria the bacteria that used to do a form of photosynthesis that did not produce oxygen, they used the pigment that didn't absorb the purple light. They didn't absorb purple light. And because of that chemical process, the reflection of the light off the surface of the planet, which was mostly covered by these purple little bacteria, we saw if you came in from space, you wouldn't see a blue ball in space. You'd see a purple ball. So it's a very good question. Let me show you what it looked like. Let me show you pictures. Start recording. So as you saw, the algae bloom can be really big and awful, and I'll show you some more pictures in a second. But one of the big problems we have, it happens here in Cleveland and all cities that form the lake. We have these sewers. It rains, right? And does anybody want a river in their street? No, nobody wants that. Nobody wants water in their basement. So we got these big storm sewers. They're big. And you see the holes in the street, they have the grates that the water feeds in. So when it rains, the water goes into the storm sewer and goes and feeds into the lake. It's storm water, so theoretically it's not like poop water, right? So it's not a big problem. Of course, you got pollutants on the surface. You got garbage, right? People throw their garbage in the street, urine, that kind of stuff, right? It's going to be what? Yeah, okay, good. So you got that water runoff, that rain runoff did always take a little bit of pollutants with it, but not so much as to be a big worry. Now, when it rains really hard, now, by the way, when you sit on the toilet, right? When you're sitting on the toilet and you poop, the poop goes down into a sewer. It goes down into a septic sewer. A septic sewer is different from the storm sewer. It's going to have all the pee and poo, okay? Is that understood by everybody?
Yeah.
And everybody's toilet all over the city feeds into the same big septic sewer. This sewer theoretically goes into a water treatment plant. We have 4 of them, I think, at least 4 in Cleveland. And they treat the water, they get the poo and the pee out of there, and they clean the water enough that they can dump it into Lake Erie, and it's safe. But in a bad storm, when it rains a lot, the 2 waters mix because we call it a combined sewer system. Before there were so many houses, it was a good idea because what happens is when you get a really bad rain, you don't want your basement flooding or the streets to flood. So the storm sewers are so big, they would be overwhelmed by too much water. So now with the combined sewer system, they're able to combine the 2 and then it lets the water run off. But then all the poop water goes right into Lake Erie. And they would put signs on Lake Erie. They say, no E. coli, no swimming today. After a big rain, you couldn't go swimming in Lake Erie because it would be full of poop. It takes a while, but the lake's ecosystem can eat the poop. But that poop turns out to lead to algae blooms. There's so much of it, it ends up being algae blooms. So now, that leads us to why your parents are paying more money for water. Your parents are paying more money for water, to drink and more sewer. There's 2 bills your parents pay. One is water bill, and the other is a sewer bill. Both are in Cleveland. Both you're paying for more money for both. The reason is we're getting rid of the combined sewer system. We're fixing the problem. We're digging big holes. We dug one here. We dug one in front of the art museum. All over the region, giant holes that hold all that water. They're not going to replace all the sewers. They're going to take all that water and hold it, a reservoir. Then they'll clean that water and then put it in the lake. So that way we reduce all the problems of pollution. We can hit it all at one point, and then we reduce that algae bloom that you just saw and the death of our lake, which is so important to us, right? All of us think that Lake Erie is important, even if you just would like to boat on it or swim in it. Most of us would like to be able to keep doing that. So it's worth it to us. And for our thought about the old people like me that pay the sewer bill and water bill, we'd rather pay more and give a future lake to you that's cleaner than when we got it. So that's the idea behind the combined sewers, the construction and the higher water costs that are happening around you today. Do you see how everything's connected? Everything's connected. Your mom or dad complaining about the water bill is directly connected to all these other things that are going on all around the world. It's kind of crazy. All right. So we're good with this idea of eutrophication? On Monday, we're almost out of time, are we not?
We are out of time.
Oh, I'm so sorry. Well,
No,
thanks
we
for your
leave here at
patience.
9:29.
Oh, and what time is it?
9:20.
Oh, we got 9 minutes.
Oh, it's 45, never mind. I thought it was 40 minutes. We came
Oh.
here at 8:40. I just did the math.
Oh, okay. That's fine. You know more. You had a better idea than I did, so I'm good. I don't know. I
they
saw
said
it.
40
I saw it in the
minutes.
bulletin, but I
They
forgot.
said
And
40,
so,
and I
all right.
8:40.
Well, we got 9 more minutes, so let me tell you what we're going to do on Monday, and then just kind of lead you. There's one last. So that's eutrophication. That's the idea of pollution and water runoff. And I'll show you some. I'll end the day with showing you pictures if you want to hold off before you get up. But I want to tell you before we stop, let me say this. On Monday, I'd like to talk about succession. I'd like to talk about how soil is made, how do we make soil, how do plants start growing in new land. We'll look at it on Monday, and I probably misspelled succession. You tell me.
I think it's two.
Somebody ask Siri or look it up. How do you spell succession?
Damn. Okay.
That water.
That's only.
Yes, two S's.
It's gonna be first time.
So 2 C's and
CCESSIOE. Yeah.
why? Why 2 S's and 2 C's?
Spell success.
I don't. It doesn't make any sense. 2 C's and 2 S's, really?